Today we are covering negative and zero exponents. All right, negative and zero exponents. So we're going to see these negative signs showing up with our exponents, and we're also going to see an exponent of zero. All right, and so we need to know what to do with that. So first rule, any zero exponent automatically makes the base value 1. It doesn't matter what your base value is. It could be a number or it could be a variable. Notice what they all have in common. They're all going to equal 1. All right, that's the rule. So anytime you see a term raised to the power of 0, it becomes 1. The variable is gone. So notice for y, the y changes to a 1. The y is gone. All right. Okay, so what happens if you actually have to evaluate a negative exponent? So we know what to do with an exponent of 0. You guys paying attention? Okay. So what if I have a negative exponent? So 3 to the negative second power can also be written 3 to the negative second power over 1. All right, that's like putting any whole number over 1. You can put a whole number over 1, right? Okay, so here's my rule. If I need to make my exponent positive, I need to flip it into the opposite side of the fraction. In this case, it would be the base. All right, so it was in the numerator. I can put it in the denominator, and it will now make my exponent positive. Now I can evaluate it. Now I can say, okay, 3 times 3 is 9. All right? Okay, so that's what we're going to start off by practicing. All we're doing in this next example is we're practicing writing a negative exponent as positive. So 3 to the negative third power. Do you see it in a fraction right now? Is it in a fraction? No, but I can put it over 1. Okay. And now I can visually see, well, if I need to make it positive, I can put it in the opposite side of the fraction. It was in the top, and now it's in the bottom. 1 over 3 to the third. Now, okay, we're just going to leave it here for now, but in the next example, we're going to solve that. Now we could solve it. 3 times 3 times 3. All right, let's look at C. So whether it's a number or a variable, I can treat it the same way. C to the negative fourth over what? 1. If I want to make my exponent positive, I just flip it to the other side. So it was on top. Now it's going to be in the denominator on bottom. 1 over C to the fourth. Okay? All right, I want you to do 5 to the negative second power. Write it using only a positive exponent. Good. So now we put it over 1 and we flip it and we say 1 over 5 to the second power. Did you guys get that? Yeah. Did y'all get that? All right, so now let's look at these last two over here. What do we notice that's different about these two? Okay, they're already in the denominator. So what do you think we're going to have to do to write them as positive? Flip them into the numerator, the top part. So for 1 over x to the negative third, now it becomes x to the third over 1, or just x to the third. Because technically you don't have to write the over 1 part. All right, when it's on top. Okay, you do y. You go ahead and do y, if you haven't already. All right, how are you going to write y as positive? All right, Hayden, what did you get? Very good. Y to the fourth power over 1, or just y to the fourth power. Give me a thumbs up if you got it. Did you guys get that? Okay. All right, very good. All right, next slide. What do you notice that's different about this next slide? What do you notice? Do you see only one base and one exponent? No, you see multiple. So here's what I need you to understand. Every term has its own exponent. Does x have a negative exponent? Does x have one? No, it doesn't. only y has a negative exponent. So the whole term gets put over 1. However, you only move the part of the term that has the negative exponent. So x to the third power is on top, right? That's where you keep it. It doesn't have a negative exponent. It stays where it is. So x to the third stays on top, okay? Now y to the negative second needs to move where? To the bottom to become positive. All right, as a matter of fact, if you were to move x to the third to the bottom, you're actually going to make it x to the negative third. Okay? So when you move a term to the other side of a fraction, you make the exponent the opposite. So if you move x to the third, you're actually going to make it negative, which you don't want to do. The goal is to make it positive. All right? Any questions? Anything? Okay, so I want you to try A, B, and C. Just want to give you guys a minute to see if you can do A, B, and C. All right, which terms stay where they are and which terms need to move. All right, go ahead and see if you can rewrite it. So which terms stay where they are, guys? The positives. Yes, okay, well, let's say it A to the second power, C to the fourth power, over B to the third power. When I move it to the opposite side, it becomes positive. All right, that's my answer. Okay, what do you notice about this bottom left problem? It's in the denominator now. My exponents are in the denominator. All right, so again, to make it positive, you don't just write it in the denominator. To make it positive, you have to put it in the opposite side of the fraction. Okay? So here's my question. Does both the x and the y need to move? No. Do they both need to move? No. No, only the x needs to move to the top. So it would be what? What would it be? Anybody want to raise your hand and tell me? Very good. Over y to the fifth power. Awesome. Okay, you need to do that before class next time. Okay? All right, so what do you notice that's different about this last one? Let's look. Not the variables, but that starts with a C. Good job. All right, coefficients. The coefficients. I knew. Hey, Ms. Vorpahl taught you well. Okay, my coefficients, guys, look here, 5 over 10. Can I reduce that? Yeah, I can. I can reduce 5 over 10. There's no exponents. Yeah, they're different bases, but there's no power, so I can just reduce that. Here's what I need you to understand. 5 over 10 does not have a negative exponent. What does? The x and the y. They are separate. So I'm going to reduce 5 over 10 to 1/2. Okay? Now, how would I write x to the negative second as positive? Would I keep it in the numerator? No, it needs to go to the bottom. And how do I make y positive? It needs to go to the top. They need to switch. So x to the second moves to the bottom and y to the third moves to the top. This is your final answer, or you could just say y to the third over 2x squared. Okay, the 1 is understood. The 1's understood. So either way. All right, how'd you guys do on that?
I don't know about that.
All right. Okay, all right, next example. Okay, so 3 to the negative fourth power. I cannot evaluate this. It has a negative exponent. So before I can evaluate, now you're actually solving these, guys. Evaluate. Before I can do that, I must make my exponent positive. So where is it going to go? It's going to go to the bottom. 1 over 3 to the 4th. Does that mean 3 times 4?
No.
Chase, turn around. Turn around. No, that means 3 times 3. 4 times. So 3 times 3 is 9. Times 3 is 27.
Times 3.
81.
Oh, great.
All right, 1 over 81.
Do you have to put 1?
Yes, you do have to put 1 over, otherwise it looks like 81. If it's in the denominator, you need the 1. Okay, now, here's your challenge for the next one. You have to evaluate this expression. Okay? You have a negative exponent. We know the rules for negative exponents. However, before you start moving that to the denominator, what do you notice about this expression?
One is positive, one is negative. Oh. Same base.
Same base. Okay? You have to solve this. You're either going to solve it the really, really hard way or the really, really easy way. Okay? So if you don't want to be evaluating negative 8.5 times itself 4 times and then dividing it, okay, you need to use product of powers. Same base, 8.5, raised to the power of negative 4 plus 4. I'm adding my exponents together. Same base, common base, add my exponents. What is negative 4 plus 4? 0. Well, that's nice. So, negative 8.5 raised to the power of 0 is not my final answer. Anything raised to the power of 0 is 1.
So would that be negative 1?
It is just 1. That's a great question. All right. Even though my base was negative, when I evaluate it to the power of 0, my answer is just 1. All right. I want you to try to do the last one. Go ahead and do the last one, please. Did anybody multiply 6 by itself 8 times? I hope not. No. Common base. Common base. Negative 8 plus 8. What's negative 8 plus 8? 0. So you didn't leave it like this, did you?
No.
1.
Of course.
All right, product of powers. Product of powers. It definitely can help you out. What do you see here that's different?
They are.
Is this product of powers anymore? Quotient. Division. All right, so 2. All right, now guys, this is why I made such a big deal about showing step 2. All right, here's your common base of 2. What 2 numbers? Anar, what 2 numbers are you going to subtract here to do quotient of powers? No, we're on the top one. No, you got to pay attention. All right, Mike? 6 minus 8. 6 minus 8. What's 6 minus 8? Negative 2. So the order is really important because can I evaluate a negative power? Chase, go ahead and move up for me. Okay? All right, I can't evaluate a negative power, so what do I need to do? Flip it. Yes, ma'am. What's 2 squared? All right, 1 over 4. Because when I changed my negative exponent and made it positive, my base was not positive, so my answer is 1/4. Because my negative changed to a positive for the exponent. All right, now on the next one, I see that I have 5 to the negative 4th power. I know I cannot evaluate a negative. However, before you just flip it, go ahead and do your product of powers. Because maybe after I do my product of powers, it's not going to be negative. Then I don't even have to worry about it. Right? So Jordan, what's 7 plus negative 4?
3.
It's 3, right? So now I have, instead of having a negative, I just have 1 over 5 to the 3rd power. Now you have to evaluate that. Remember, guys, we're evaluating in this example. What is 5 times 5?
25.
What's 25 times 5?
75.
Nope.
100.
Nope.
125.
125.
Oh.
1 over 125. All right, I want you to do the last one. So, most of you did negative 3 to the power of 5 minus 6. Okay? Negative 3 to the power of negative 1. You can't have a negative exponent. Well, some of y'all just magically made that positive and you didn't flip it. You got to flip it. 1 over negative 3 now to the positive first power. This is still not your answer. You have not evaluated your power. It's a 1, I know, but you have to evaluate it. All right? Right, Mike? So that's what you did. That's what John did. Okay? So it is negative 1/3, or you could say 1 over negative 3. Either one would be your answer. No parentheses. You cannot have the parentheses. The parentheses mean that you have not evaluated it. Okay? So the parentheses are gone once you evaluate the power. All right? I know you think, well, it's the same thing. Theoretically, yes. But to evaluate a power means the power is gone. It's absorbed into the base number. All right, yes, absorbed. It's like, it got eaten. Okay? All right, last slide for today. This is our last slide for today. All right? Negative 5x to the power of 0. Negative 5x to the power of 0. I want you to simplify this. So you might not be able to get to the whole answer. Maybe you can. Actually, on the first one, you can. All right? But if you don't know what the variable equals, there's only so much you can do. Okay? You must understand this step. This means, I want you to write this down. Negative 5 times x to the power of 0. Does negative 5 have an exponent of 0? No, it does not. X does. It's not negative 5x to the power of 0. Okay? It's negative 5 times x to the power of 0. So anything raised to the power of 0 is 1. So this means negative 5 times 1. What's negative 5 times 1? Negative 5. That's my answer. The x is gone. So I know it's hard to wrap your head around, but anything raised to the power of 0 becomes a 1. Yes. What do you guys think about this next one?
It's ugly.
Okay. All right, so I've got a 9. Can I do quotient of powers with my y's? Yeah, do I have same base and I'm dividing? Yeah. Okay. So I can subtract all 5 of my powers of 5. Okay, so I can subtract this into the numerator. Guys, when you do that, you're moving this entire term to the numerator. All right, so y to the power of 5, when you subtract 5 from negative 3, you're moving that entire term up. That's important. So I have 9y to the power of what is negative 3 minus 5. We're almost done. Negative 8. Okay? Over 1. Not y. I have a lot of people try to leave a y in the bottom. When you subtract all of those exponents into the top, that moves the entire term up. So let me ask you this. Do you move the whole term? Does the 9 have a negative exponent? You only move the y. Don't move the 9. You say, well, 9 doesn't have an exponent. Yes, it does. It has an understood 1. Yes. 9 has its own exponent. 9 does not have an exponent of negative 8. Y does. Okay? So it's 9 over y to the 8th power. This is going to take some practice. All right? Hopefully we're making progress. You're not ready for your test tomorrow. Not even ready for a quiz. That's why we're reviewing. Okay?
2 days.
All right? Quiz is in 2 days. Then we have 2 more review days where we're really going to get smarter. Then you have your test. Okay? All right. I want you to try this next one. I think some of you are going to get this. This is not an easy problem, okay? It really takes some concentrated thinking. But let's see who can get this next one right. When you have the answer, raise your hand. I want to come look. Okay, so what is 4 plus negative 7?
Negative 3.
N to the negative 3rd power over 6, okay? Now, we know we can't have a negative exponent, right? So what needs to happen to my n? I need to move it where? To the bottom. Does 6 have a negative exponent?
No.
No. So it stays where it is.
What? Are you kidding me?
It doesn't have a negative exponent. You don't flip the entire fraction. You leave the 6 where it is. So what's on top then? A 1. 1 over 6n to the 3rd power. Good job, Chase.
All you had to do is tell me that it needed to be a negative 3.
Okay, yeah, see, there you go. All right. Okay, so we're gonna end it for today. Okay, right here.